Good morning. Today we will talk about congruent triangles. If we look well at these three triangles, in the first one we have the measure of the length of the first triangle 4, 5, 7. In the second triangle, the three sides measure 4 centimeter, 5 centimeter, 7 centimeter. And also the third one with the same measurement 4, 5, 7. Even if they don't have the same direction. All of these triangles have the same measure of sides, then we call them congruent triangles. اوكي congruent يعني متطابقين، يعني إذا حطيتهم على بعض بيتطابقوا fit exactly. The justification is that they all have exactly the same sides 4 centimeter, 5 centimeter, and 7 centimeter. But if we look here, the first triangle, its sides are 4, 5, and 7. The unit used is centimeter, of course. The second one has 5, 6, and 7. Since they have different measures, then I can say that these triangles are not congruent. They don't have the same measure of the sides. يعني إذا قصيته على ورقة من بعد ما رسمته وحطيتهم على بعض ما حيتطابقوا، حيضل مبين واحد أكبر أو أصغر من التاني. Okay? We say that triangles are congruent when they have exactly the same measure of sides, when they fit exactly on each other. That's what we talked about sides. But does this also work with angles? It's not a rule. It's not always true. If they have the same measure of angles, here for example 30, 40, and 110 degrees, in our case here they are congruent. If they put them on each other, they fit exactly. Why? Because they have the same measure of sides. Okay? But here in the other example, even if they have 30, 40, and 110 degrees, they are not congruent. The first one is obviously greater than the other. So if we draw them on the same paper and cut them and put them first one above the other, they don't fit exactly, so they are not congruent. And having three equal angles is not always a rule. Up till now the rule is I must have three equal sides in the two triangles to say that they are congruent. What are the elements of the triangle? We know that triangle is a polygon that has three sides, three angles, and three vertices. The vertex is the point of intersection of the two sides. When we say that two triangles are congruent, this means that all the elements must be the same. I mean, the three sides on both triangles should be equal. The three angles on both triangles should be equal. Here, for example, we have triangle ABC and another triangle PMN. If you look well at the sides, we have given that AB is equal to MN since they draw the same sign on the both sides. Similarly, AC equal to PM and BC equal to PN. Look at BC and PN, there are three dashes, so it's a sign that they are equal. What about the vertices? Here, if we put them on each other, the vertex A fit exactly on M, B fits on N, and C on P. We can rotate our triangle as much as we want until they fit on each other. When we talk about congruent triangles, we have congruent elements and homologous sites. What's the difference between them? The congruent sites here, for example, I told you that AB and MN are equal because they have the same measure. AC equal MP and BC equal NP. I'm comparing the two triangles, okay? When I say that I have three elements that are equal, here for example, three sides on the first triangle is equal to three sides on the second triangle, so definitely our triangles should be equal. The other elements that are, by conclusion, equal to each other are called homologous elements. We know that I'm talking about three sides and three angles. Since three sides are equal to each other, the triangles are congruent, so the angles are equal to each other. Here, for example, CAB, the angle with vertex A, it holds two sides, AB and AC. Look with me at the second triangle. A, the vertex A fits on angle M. How did I know that? AB equal to MN and AC equal to MP. Here, angle A is holding two equal sides. The sides that are equal on the other triangle are MP and MN. So the angle BAC equals to PMN. Okay? Similarly, I can say that angle CBA equals to, here this angle CBA equals to this angle MNP. How did I know that? We have here this side MN equals to AB and PN equals to BC. So the angle holding the equal sides should be equal to each other. Similarly, ACB, this angle, equals to MPN. Look at the holding sides, they are equal. There are three ways to find if two triangles are congruent or not. The one that we discussed before is side, side, side. Three sides are equal. Okay? For example, here we have two congruent triangles simply because they have three equal sides. The first one equals to 4, the second equals to 5, and the third equal to 7 centimeter. So they are congruent. Okay? Let's have an example. Here, given two triangles, I must say that in the two triangles ABC and DEF, we have, now let's see, CB equals to 5 and EF equals to 5, then I can say that CB equals to EF. Similarly, AB equals 7 and DE equals 7, then AB equal to DE. Okay? And AC equals to DF equals to 9 centimeter. Here I proved three elements that are equal on both triangles. Then I'm talking about congruent triangles. Definitely the other elements are equal to each other. So that's what I call them homologous elements. Here I have to mention which postulate I used to prove. I mean, here I used side, side, side to prove that they are congruent. Then, what are the homologous elements? Here, the angle holding the 5 and 7 centimeter sides equal to ABC. Then 5 and 7, the vertex or the angle holding them is DEF. So I can say that ABC equals to DEF, and similarly BAC equal to EDF and BCA equal to EFD. The second postulate is side angle side. Here, for example, look well at this figure. I have to prove two equal sides and the angle which is between them should be equal. For example, here we have this side measures 3.6, the also this one 3.6. The other side measures 7.1 and in the other triangle 7.1 centimeter. The angle holding the two equal sides here equals to 49 and this angle here equals to 49. So if I look well at this triangle and I rotate it here, إذا رسمته على ورقة وقصيته وقلبته, it fits exactly on the second triangle. They are congruent triangles. Okay? Here, let's see an example. Given the following figure, kj equals to kn. How did I know that? They put the same sign. It's a given. And the same sign is put in here on the angle jka and akn. So they are equal. Okay, we have here side, angle, and what about the other side? Look, KA is a common side between the two triangles HJK and AKN. So I can clearly say that these two triangles are congruent. What are their homologous elements? When I say that they are congruent, I have to decide which postulate did I use. Okay, so here for example, I say AK equal to AK, or AK is a common side, JKA, this angle equal to AKN, and we have KJ equal to KN. So here the postulate is side, angle, side. What are the homologous elements? Since they are congruent, so I can say here that JA equals to AN. اوكي اذا طويته لهيدا التريانجل على ال AK وبرمتهم على بعضهم, it fits exactly. So JA equal to AN, they are homologous element. Now we still have here this angle JAK equal to KAN and HJK equal to ANK. These are the homologous elements that I should mention. Now, the third and last postulate is angle side angle. Let's see an example. Here we have this side measures 8.9 centimeter and the two angles here are equal. So I can say that these two triangles are congruent and I have to search the homologous element. Here, for example, I have to prove that LMN, this triangle here, LMN, is congruent to NOP. Let's see, what do we have as a given? Here we have 35 degree. And we know that when we have this shape, I can say that ONP is equal to LNM, equal to 35 degree vertically opposite angle. I may use this given. We have 60 degree angle and this one is 4 centimeter. Let's see it together. The two triangles LMN and NPO, I have to detect the triangles first. بدي أقول عن أي triangle عم بحكي وبعدين بقول شو هن الإيكوال وشو هن الهومولوجس. Here we have LM equal to PO equal to 4 centimeter. LMN equal to NPO equal to 60 degree. What about MLN? Here, since this side LM, then I'm searching about, did I know about MN to say that it's angle side angle? They didn't give me its length. So I have to calculate this angle here. MLN equal to 180 minus 35, which is minus 60 of course, equals to 85 degree. Similarly, I can say that these angles are vertically opposite angles, so NOP also equals to 180 minus 60 minus 35, which is 85 degrees. We have three elements proved to be equal to the three elements on the other triangle, so they are congruent by angle, side, angle postulate. So the other are called homologous elements. Ln equal to NO and Mn equal to MP, and these angles I told you about them before. Okay?